Hello everyone, welcome to this video. In this video we'll talk about how to balance redox reactions in an acidic medium. We learned about how to balance redox reaction using oxidation numbers. Now we will talk about how to balance redox reactions using two half reactions, using oxidation half reaction and reduction half reaction. We will separate these two reactions and then we will balance using acidic medium. When we say acidic medium, we mean addition of H+. So we will proceed with the material of electrochemistry and a quick recall to the old material. The first thing I want to mention is that oxidation half reactions. What oxidation means? Oxidation is the process where a chemical species lose electrons, and reduction half reactions. Reduction means the process in which a chemical species gain electrons. Together they form the redox reaction. Redox reaction is where the chemical species are involved in oxidation plus reduction. Okay, so there is transfer of electrons from one chemical species into another. This is a redox reaction, or we say it's overall reaction, the overall reaction, which mainly is the addition of the oxidation with the reduction reaction. Okay, so we use the when the chemical species are becoming more complex, it's not easy to guess it from the side. I mean, we were talking about Cu2 plus is becoming Cu, Zn2 plus becoming Zn, let's say Ag is becoming Ag plus. So I mean, it was easy for us, but when the chemical species are becoming more complex, several atoms are involved in one chemical species, such as, let's say, Cr2O7 2-. So it's really hard to know if this chemical species gain electrons or lose electron. So we invoke something which is called oxidation number in order to track the electrons inside the inside the chemical species. So if the oxidation number increases, then it's oxidation half reaction. If the oxidation number increases inside the chemical species, then it's undergoing oxidation. And if the oxidation number decreases inside a chemical species, then it's undergoing reduction. What I want to mention here is that in oxidation reduction reaction, there is a change in oxidation numbers of the atoms involved. So if the reaction is redox, there must be a change in the oxidation numbers between the chemical species. Okay. So the main objective of this video, by the end of the session, you will be able to balance redox reactions between balanced redox reactions in acidic medium. When we say in acidic medium, we mean in the presence of hydrogen ions. And the example that we will talk in this session, we will talk about is the iodide. Iodide is I-, and the permanganate is MnO4 minus. These are the two examples that we are concerned of, and we will talk about inside this lecture. So, as I've mentioned in the slide before that, the example that we will talk about is MnO4 minus is reacting with I minus, is giving us I2 plus Mn2 plus. So this is the overall redox reaction, but this redox reaction is not balanced. Now we need to balance this redox reaction. In order to do that, we will divide this redox reaction into two half reactions, the oxidation half reaction, the reduction half reaction. And after dividing these two reactions, we will work on each half reaction and we will try to balance each half reaction. And then after balancing each half reaction, we will add the two half reactions together to form the balanced redox reaction. Okay, and it's important to mention that we can know if it's reduction or oxidation. We can deduce if it's the reduction or oxidation by the location of electrons inside the reaction. For example, let's say this is Cu. If we have Cu2 plus 2 electrons is giving us Cu. We can know that this is a reduction half reaction. Why it's reduction half reaction? Because the electrons are in the reactants. Okay. And if we have another example, which is Cu is giving us Cu2 plus 2 electrons, we can know that this is an oxidation half reaction. Why it's the oxidation half reaction? Because the the location of electrons are in the products. So this is an oxidation. Okay, so this is reduction, and this is oxidation. Now, we can know that after balancing the half reactions, we can deduce whether it's reduction or oxidation through the location of electrons, or we can calculate the oxidation numbers to start with inside the reaction, inside the main reaction, the redox reaction, the unbalanced redox reaction. So let's say that I'm gonna start calculating the oxidation number of Mn. Mn is MnO4 minus MnX, I don't know it. The oxidation number of oxygen is equals to -2, but I have 4 oxygens, so times 4. The overall charge is equals to -1, then it's equals to -1. X -8 is equals to -1, then X is equals to 7. So here the oxidation number of Mn is equals to 7. Okay, now the oxidation number of I minus is equals to -1. The oxidation number of I2 is equals to 0. And the oxidation number of Mn2 plus is equals to +2. And here I can deduce which is undergoing oxidation, which chemical species is undergoing oxidation, and which chemical species is undergoing reduction. So let's talk about manganese, Mn. It was MnO4 minus, then it becomes Mn2 plus. Please note that this half reaction is not balanced. This half reaction here is not balanced. MnO4 minus is giving Mn2 plus. This is not balanced. Okay. Now Mn, it was 7. The oxidation number was 7. Then it becomes +2. This means that the oxidation number decreases. When the oxidation number decreases, this means that it's reduction half reaction. Okay. Now let's talk about the second half reaction, which is I minus. I minus was I minus, then it becomes I2. I don't know if it's reduction or oxidation, but I can deduce that this is reduction. I can deduce this is oxidation if the overall is redox. Now let's see. -1, it was -1, then it becomes 0. This means that the oxidation number increases. This means that it's oxidation half reaction. Okay. So let's see the oxidation numbers. In the left hand side we have +7, -1, the iodide was -1. The right hand side we have +2 and 0. This means, as I've mentioned, that the manganese is undergoing reduction half reaction. MnO4 minus is undergoing reduction half reaction to become Mn2 plus, whereas I minus is undergoing oxidation to become I2. Note that these two half reactions are what are not balanced, and this redox reaction is also not balanced. Okay, so let's proceed. So the first reduction half reaction, as I've mentioned, that here the oxidation number decreases, which means that it undergoes reduction. In the reduction half reaction, MnO4 minus is becoming Mn2 plus. The first thing we need to balance is the atoms that are being reduced. What do we mean by the atoms that are being reduced? Here we have Mn the metal. We have one Mn here, and it becomes 1 Mn here. 1 Mn here, it becomes 1 Mn here. So it's already balanced. Here we have 1 Mn, and 1 Mn. So it's already balanced. So after balancing the atoms that are being reduced, we will get MnO4 minus becoming Mn2 plus. So first step is checked. Okay. The second step is we need to balance the oxygen atoms by adding water molecules, H2O, okay, to the side that needs oxygen. Here we have MnO4 minus, it's becoming an Mn2 plus. We need to balance the oxygen here, the oxygen atoms. We need to add water molecules. We balance the oxygen atom by adding water molecules to the side that needs oxygen, which means in the right hand side, right? So we have here we need 4 oxygen atoms in MnO4 minus, right? So we have MnO4 minus is giving Mn2 plus H2O. How many H2O? 4. Here we have four oxygens, and here we have 4 oxygens. So the atoms, so the oxygen atoms are being balanced inside in the second step. Okay. Now the third step, we need to balance the hydrogen atoms by adding H plus ions to the side that needs hydrogen. So if you still remember, it was MnO4 minus, right? It's giving us Mn2 plus 4H2O, right? Now here we need to add hydrogen ions, H plus ions, to the side that needs hydrogen. So it's obvious that the hydrogen ions are not balanced. Here we have 4 H2O, which means here we have 4 times 2 is 8 hydrogen ions, and here we don't have anything. We have 0 hydrogen ions. So for this reason, we need to balance the hydrogen ions by adding H plus. MnO4 minus plus, we need H plus ions, 8 H plus ions, to give us Mn2 plus 4H2O. Notice that now the matter are being balanced. The reaction in terms of matter is being balanced. Here we have 1 Mn, 1 Mn. 4O, 4 oxygen atoms, we have here 4 oxygen atoms. 8 hydrogen atoms, here we have 8 hydrogen atoms. But we have the last step in balancing this reduction half reaction is the charge. The charge is not being balanced. Here we have the charge of this is plus 7. We have 8 hydrogen, we have minus, so plus 7, and here we have the charge here is plus 2. So the charge is not balanced. So for this reason, we balance the charge by adding electrons. So all what we have to do now is to add electrons so that we can balance the charge. So we have, for the plus 7 to become plus 2, so that these two equals, we need to add 5 electrons, right? So that 7 plus minus 5 is equals to plus 2, right? This is a side note. Let's say this is a side note. So here we have MnO4 minus plus 8 H plus. Now we need to add plus 5 electrons. It's giving us Mn2 plus 4 H2O. And by this, we were able to balance the reduction half reaction in terms of matter and in terms of charge. Okay, so here the charge is a plus 2, right? And here the charge is plus 2. The right hand side, the charge is plus 2, and the left hand side, the charge is plus 2. Mn. 8 hydrogen atoms, 8 hydrogen atoms. Okay, 4 oxygen atoms, 4 oxygen atoms, and the charge is balanced. So this is the last step. This is how to balance the reduction half reaction. Now we will go to the oxidation half reaction. The oxidation half reaction in this case was I minus is giving us I2, right? I minus is giving us I2. So iodide is giving us I2. The first thing to do is to balance the atoms that are being oxidized. So Here we have one iodide minus is giving us I2. This means that the iodide are not being balanced, the iodide atoms. So the first step, what are the atoms that are being oxidized, which is I. 2I minus is giving us I2. This is the first step. Check. Now the second step, as the previous one in the reduction half reaction, we need to balance the oxygen atom by adding water molecules. Okay, we don't have here oxygen atoms, so we will go to the next step. We don't have oxygen atoms, so we will leave it. We don't need to balance oxygen atoms. We don't have oxygen atoms to balance, we don't need to add water molecules. The third step, as the previous, we balance the hydrogen atoms by adding H plus ions, as the previous one. But we don't have hydrogen atoms, so we will go to the next one. Now here, in the last one, balance the charge by adding electrons. Here it's obvious that the charge are not being balanced. Here we have -2, and here we have 0. So in this reason, we need to add, by adding electrons, we need to add electrons. So 2I minus is giving us I2. Here we need to add electrons plus 2 electrons. Now if you look, the oxidation half reaction is balanced in terms of matter and in terms of charge. Notice that this is oxidation. Oxidation half reaction, we concluded that oxidation from the increase of oxidation number. But we also can conclude after balancing the oxidation half reaction that it's oxidation because it loses electrons. You can see that 2 electrons are in the products. Whereas if we return back to here, you can see that MnO4 minus, the electrons are in the reactants, which means that it's reduction. So let's proceed. So the overall reaction is, we have 2I minus is giving us I2 plus 2 electrons, right? And MnO4 minus plus 8H plus 5 electrons is giving us Mn2 plus 4H2, right? As I still remember. Let me check. Yeah, MnO4 minus 8. Yeah. So here we have these two half reactions. This is, as you can see, this is the oxidation half reaction. This is the reduction half reaction. Now, how can we conclude the overall redox reaction? First, we need to multiply both reactions by an integer so that the electrons will be cancelled. So what we need now is to cancel the electrons. And we need to multiply each reaction by an integer so that the electrons will be cancelled. So here we have 2I minus. If we multiplied the 2 by 5, multiply the 2 by 5, and we will multiply the 5 by 2. Let's see if the electrons can be cancelled in this case. So here we have, if we multiply it by 5, then we will get 10I minus is giving us 5I2 plus 10 electrons. And 2MnO4 minus plus 16H plus 10 electrons is giving us 2Mn2 plus 8H2O. Okay, so here we have the electrons here in the product, here the electrons in the reactants. We can cancel the electrons with each other and we can get the overall reaction 10I minus plus 2MnO4 minus plus 16H plus is giving us 5I2 plus 2Mn2 plus 8H2. I just canceled the electrons. The electrons that are being lost by the iodine are being gained by the permanganate. 10 electrons are being lost by 10 I minus are being gained by 2 MnO4 minus. So the overall reaction is this is the overall reaction is 10 I minus plus 2 MnO4 minus plus 16 H plus is giving us 5 I2 plus 2 Mn2 plus 8 H2. Now the last step in the overall reaction, and we will end the video with it, you need to verify that the final balance equation is balanced with respect to charge and mass. How to verify? We need to check if we committed any mistake in the previous steps, so that we need to verify that the final equation is being balanced. Let's see. Here we have 10 iodine atoms, and here we have 10 iodine. 5 times 2 is 10. So the iodine atoms are being balanced. 2 Mn atoms, 2 manganese atoms, and here we have 2 manganese as well. 4 oxygen atoms. Here we have 4 oxygen atoms, but 4 multiplied by 2, we have 8 H2O. Okay, it's balanced. 8 H2O, I mean 8 oxygen atoms, and here we have 2 times 4 equals to 8 oxygen atoms as well. 16 hydrogen atoms, hydrogen ions, and here we have also 8 times 2 is equals to 16. So this redox reaction is being balanced in terms of matter. Let's check in terms of charge. Here we have minus 10, minus 2, plus 16, minus 10, minus 2 is minus 12. Plus 16, here we have the charge is equals to minus 4. Sorry, minus 10, minus 2, plus 16, here is the charge equal to plus 4. And here we have 5I2 plus 2, Mn2 plus, here the charge is equals to also plus 4, which means that the charge is being balanced. So the last step, verify that the final balance equation is balanced with respect to charge and mass is also checked. Now one last remark of why did we consider that we are balancing here in acidic medium, and why it's important to mention an acidic medium and not any other medium. If you just remember that we added, in order to balance the hydrogen atoms, we added H+. H+ mainly comes from the medium that the reaction is being taken place. So we performed the reaction in acidic medium, and that's why we were able to add a hydronium or hydrogen ions inside the reaction, and the reaction should be aqueous so that we can add H2O molecules also to balance oxygen atoms. So that's it. If I want to mention one last note, that if the reaction was dry redox reaction, we can balance using the acidic using this way, because dry redox reaction we don't have free hydrogen ions, so we can't balance the hydrogen ions in hydrogen atoms inside the reaction. So dry redox reactions, we need to use only the oxidation number method. We can't use this method in order to balance redox reactions. There are another method using the same thing, but by adding OH minus, and this is when we perform the reaction in basic medium. We will talk about it later on. Now, concerning the hydrogen ions, concerning the acidic medium, when we perform the reaction in acidic medium, we can balance the hydrogen atoms by adding hydrogen ions, and we can balance the oxygen atoms by adding water molecules. And the sequence of steps should be respected. We start by balancing the atoms that are being oxidized or reduced. Then we go to balance the oxygen atoms by adding water molecules. We balance hydrogen atoms by adding hydrogen ions, and then we balance the charge. The steps should be respected. Okay, you should follow the steps. I mean, you should follow the same exact steps. Okay, for this this is the end of the video. Hope that you enjoyed it and hope that we were able to fulfill the objective behind this video. Thank you.